All right, so if I have to solve a problem graphically, currently in this problem like 525, which I just took out of your book, I really don't have a way of solving when I have x up in the exponent spot there. So the only way that you currently know how to do this is to solve it graphically. We'll be learning a way later on that is more algebraic. So I'm going to take out my graphing calculator and I'm going to graph the line 3x minus 1. I'm also going to graph the exponential equation 2 to the x, y equals 2 to the x. And I don't know what my window's set at, but I'm going to hit graph and see what shows up. There's the line. There's the exponential equation. So remember that I'm looking for the x value where these two things are equal to each other. So if I look at the current window that I have, I see that that happens somewhere in there. But I'm going to expand this out. It looks like maybe for my window, the x min, I don't have to really go very far. I could just go to here. Y min, I could care less about that. I might want my window to be maybe around like this. So when I look at my graphing calculator and I'm setting up my window, maybe go to -2 for x and +5. And then for y, maybe start at 0 and go up to 7. It doesn't really matter as long as I can get those two intersecting points. And now let's take a look. There's the line, there's the exponential. Hope I didn't go high enough on the y-axis. So I'm going to go back to window and I'm going to check out my y max and maybe I'll go up to 9. Now when I look at that, I see my line, I see the exponential, and I see where they both cross. And so what I'm looking for is nothing else matters except for the x values because I'm not being asked anything about y here. Y was never even mentioned, only x's. Now one way that I suggested that we can find those intersecting points is if you hit second and trace, it'll take you to this calculate screen. And number 5 is intersect. So I hit number 5. It'll ask me, is this the first curve? I just hit enter saying yes. It'll say, is this the second curve? And I'm blinking cursor there, so I say yes. It asked me to make a guess, so I just hit enter again. And they intersect at 1, 2. So my pixelated graph didn't make that too obvious. But then I noticed that there's another intersecting point. So I'm going to do that same process again. So second calc or second trace will take you to the calc screen. 5 gets you to intersect. And I'm just going to arrow over to see which. And sure, we'll take that'll be my first curve. That'll be my second curve. Now when it asks for a guess, I'm going to just arrow to the right until I get closer to that intersection. And I went a little bit too far. So I'll come back down and I'll say there's my guess. Yep, it looks like 3, 8 is the other point. And so my x values are 1 and 3. Now I'm going to take those and plug them in and see if it's true. 3 times x minus 1 has to equal 2 to the x. So the first time around I'm going to plug in 1. 3 times 1 is 3, minus 1 is 2, 2 to the 1 is 2, so that works. Second time around I'm going to plug in 3. 3 times 3 is 9, 9 minus 1 is 8, 2 to the third is also 8. So they do both work. So there's my answer for that problem.